The goal of landing men upon the moon is the most notable and impressive feat in NASA's history, but none of it could have been possible were it not for the contributions of Project Gemini, the program intended to develop and test every technique that would make the Apollo lunar strategy possible. Techniques like long-duration spaceflight, extravehicular activity, orbital maneuvering, rendezvous, and docking. Every one of these had to be completed successfully if Apollo were to have a chance of succeeding. At the time, the only craft NASA had flown was the cramped one-man Mercury spacecraft. Gemini would follow a very similar design concept as it was developed by the same contractor, McDonnell Aircraft. Whereas Mercury was a one-man sardine can, Gemini was instead compared to a two-seat sports car. The astronaut who would spend the most time helping McDonnell during Gemini's development was Mercury veteran Gus Grissom, slated as backup command pilot for the first manned flight. He worked closely with McDonnell during design phases of Gemini and offered himself as a model as the basic frame of the craft was built. This presented a minor problem, as Grissom was no tall man, and the new Gusmobile was simply too small to fit any of the taller astronauts, and therefore had to be redesigned. Still, his other inputs were far more favorable, notably designing the flight controls around the idea of jet aircraft, including the artificial horizon indicator rather than the typical 8-ball. And there were even developments into a winged glider landing system to carry a returning Gemini spacecraft to a runway landing instead of a water splashdown. But the latter proved to be less complex and less costly, however. While Gemini continued development, NASA needed a new booster. While the Atlas worked very well for Mercury, it simply wasn't powerful enough to lift the new larger vehicle into orbit. But another Air Force missile had shown potential, yet much like Atlas, was plagued with problems in initial development. Not as serious as complete structural failure, but serious enough to prevent any manned mission from flying. One such issue was a phenomena that NASA called pogo oscillation. As the name implies, this is a vibration in which the vehicle moves abruptly up and down along its length, like a pogo stick. Even though most of the typical early development problems were being addressed, the Air Force was unable to completely correct the pogo problem, and even began to seem less and less interested in doing so. Their priority was developing the Titan II as a ballistic missile, intended to deliver warheads rather than manned vehicles, and the burdensome regulations that NASA required to consider the Titan man-rated were far greater than the specifications required to ready Titan as a weapon of war. And once those requirements were met, the Air Force concluded its improvements, as they were in charge, not NASA, and the ballistic missile program took greater priority. While the Ballistic Systems Division assured NASA that it would help the best they could, they finally declared the reduced pogo of 0.6 G good enough, despite NASA pushing for a goal of 0.25 or less, and the BSD did not feel it was worth the time or resources to correct any further. Meetings between the Air Force and NASA would go nowhere, as national defense matters remained as priority at all times, even as NASA announced that if these problems could not be fixed, it could never be ready to carry human passengers. It would not be until the Air Force developed a plan to utilize Gemini spacecraft hardware for their own reconnaissance and defense programs that they finally gave the pogo problem any serious consideration. Finally, work would return on solving this issue, but only on the condition that it did not delay the ICBM program in any way. It would take through an entire year to fully shake down and ready the Titan for manned flight, and after 2 successful unmanned Gemini launches, it was now time to put the new vehicle to the ultimate test, and begin America's first 2-man space program to prove they were capable of reaching the moon. The 2 men selected to make this first flight were Tom Stafford, a rookie from NASA's second class of astronauts, as well as America's first man in space, Alan Shepard. This selection was short-lived, however, as Shepard would be pulled from the flight due to an inner ear infection, potentially resulting in severe vertigo during flight. As Deke Slayton, director of flight crew operations, did not wish to break up the 2-man crews, Stafford found his seat lost as well, Instead, the backup team got the honor of flight: rookie John Young and the man who had helped in Gemini's design, Gus Grissom. On March 23, 1965, Gemini III was ready for flight. Much like Mercury, the number was merely an official designation, as each flight was intended to carry a special call sign assigned by the astronauts. Through Mercury, each of the original 7 included the number 7, as well as a name that carried special significance to the mission or the man inside. For example, Grissom's Mercury flight was named Liberty Bell 7, as a symbol of freedom in the United States. Gemini 3, on the other hand, he chose something NASA was unprepared for. Ever since Liberty Bell 7 sank after its mission, Grissom was stuck with the unfortunate reputation as the man who lost his ship. In an effort to stick this in everyone's face, he named his Gemini spacecraft the Unsinkable Molly Brown, a reference to a Broadway musical involving a woman named Molly Brown who survived the sinking of the Titanic. When NASA urged Grissom to change this name, he jokingly suggested Titanic instead, so they allowed him to keep it. But as a consequence, no astronauts would be allowed to name their Gemini spacecraft afterward. It is very unfortunate, as the crew of Gemini 4 had selected American Eagle as their call sign. But one could only wonder what the jovial crew of Pete Conrad and Gordo Cooper would have named Gemini 5. Countdown proceeded without incident, and in the final moment of engine ignition, a loud whooping sound filled the air before the 2 main engines ignited, a sound that would become customary in every Gemini Titan flight. The long, slender, polished silver rocket lifted into the sky, leaving an almost invisible exhaust trail, customary of its hypergolic fuels. A notable visual difference of Gemini, compared to all other NASA manned vehicles, was the lack of escape tower at the nose. Along with the craft's similarity to jet aircraft instrumentation, it also contained instead an ejection seat system that could be activated manually from inside should the situation arise. Fortunately, it was never needed in flight, and would have been extremely dangerous if it were. 2 minutes into powered flight, the main engine exhausts its fuel and cuts free, shedding the vehicle of 2/3 of its overall mass. The connecting skirt falling free shortly thereafter, leaving the second stage to carry Molly Brown all the way into orbit. The planned mission was relatively short, 3 orbits to test the new vehicle. Integral to this test was something that had never been done in manned spaceflight, even by Russia: actually maneuvering in orbit. In addition to directional thrusters that would change Gemini's orientation, several translational thrusters allowed for not only motion in all 3 axes, but gave Gemini the capability to actually change its orbit. An hour and a half into flight, Grissom used these thrusters to reduce Molly Brown's elliptical orbit to a more circular one, performing the first ever orbit altitude change in history. A couple more maneuvers were made during flight, culminating in the 3rd orbit, in which the perigee was reduced to 72 kilometers. This way, if the retro rockets had failed, atmospheric drag would bring Molly Brown back to Earth in enough time for the crew to survive. Before then, however, an incident occurred that could have presented trouble for the crew. Nothing mission-related, just potentially some disciplinary action, as John Young snuck a contraband corned beef sandwich on board in his suit pocket. Each man took a few bites of this strictly non-regulation treat before putting it away, as not to risk crumbs from getting into the craft's electronics. While the 2 men were reprimanded, they weren't removed from flight status, particularly as John Young would go on to have one of the longest and most varied careers in NASA history. It was now time for the final test, as Molly Brown turned away from its direction of flight and shed its equipment module, revealing the retro rockets hidden inside the remaining 1/3 of its white adapter section. Each of these 4 retro engines fired in sequence, and retrofire was accomplished perfectly before the retro module was finally jettisoned, leaving just the black spacecraft itself and its heat shield ready to do its work. A special test was conducted during re-entry, in which a jet of water was streamed from outside the craft, in an effort to pierce through the ionization effect of re-entry and allow for communications during the fiery plunge. This did not work, nor did it impact descent in any way, and Molly Brown emerged from blackout, its crew in good shape. Parachutes deployed and began to slow descent, and just as designed, the craft tilted horizontally before splashdown, rather than landing on its blunt end. This was intended to free Gemini from the need of deploying a landing bag and potentially prevent a situation in which the bag could deploy in flight, which would cause the Gemini to lose its heat shield, the way John Glenn's flight of Friendship 7 didn't do. Molly Brown hit the water and recovery forces moved in. The ocean waves were of no consequence to Navy pilot John Young, but Grissom was Air Force, and he became seasick from the motion. Yet despite vomiting badly inside the craft, he kept that hatch door closed. There was no way he would allow the unsinkable Molly Brown to betray her namesake. And true to his promise, Grissom had brought the spacecraft back safely. Grissom and Young had flown a perfect mission, and Gemini was now ready to make history, pushing the boundaries of technology and innovation as it tackled a crucial piece of the lunar strategy with each and every mission. It was truly an unsung hero of the space race, but one that contributed more to its success than any other. And it all began right here with its first successful manned flight, in a moment that will forever mark this week in space history.